Yeah, students, now we will see a few more problems on these special cases. This is the point P. NP of a line PQ is 50 away from both the reference planes, and the other end Q is 20 in above HP and 25 in front of VP. Draw the projections of the line PQ and find its true inclinations with HP and VP if the length of the line is 60 So true length is given, no angle of inclinations are given, but instead the NP is given, NP distance is given, that is 50 away from both the reference planes, that is in front of VP and above HP, both it is 50 and other end Q is 20 above HP and 25 in front of VP. So it is very easy to solve this kind of problem, even though there are no inclinations given, because the true length is known and the end positions are also known. So the locus of Q will be obtained very easily, right? Q dash and Q. So we will start the problem. It is XY reference line as usual, 50 above HP and 50 in front of VP. So this is the first point, that is the P point. So we get P dash here. So if we draw the projector a thin line, so on that line we get P here. So this is P and P dash. So this is the fixed point. It is little away from XY reference line, and the other point 20 above HP and 25 in front of VP. So draw 20 above HP. So this becomes our locus of Q dash, and this 25 in front of VP. This line will be our locus of Q. So we got both the lines. So here, once we have these two, it is easy to get the other points. So here the true length is known 60 from P dash. Just draw an arc on locus of Q dash, because we know 60 Now P dash has center on Q dash, locus of Q dash. You draw the line and mark the point Q1 dash. So this is Q1 dash, and draw a thin line, and this is the dimension 60 So you connect this with a thin line and drop down till locus of P. So this is the locus of P line, and this will be your corresponding Q1. So this is the top view of the line, and PQ1. Now we have to rotate this up to locus of Q, and this is the Q point. So this is our final Q point, and we can draw the thick line. We know the true length, and P as center. Locus of Q line, we can draw an arc. So this arc we can connect it, and this can be called as Q2, and P and Q2 can be connected, and this should be projected up to locus of P, and we get Q2 dash. So this is the Q2 dash, and now P dash and Q2 dash as radius, P dash as center. Rotate this up to this locus of Q dash line. So this is the direction of rotation, students. You should not miss this to represent in your drawing. It is very important to get full marks, right? So this direction of rotation you have to show. So this will be your Q dash. So this is your final Q dash, and draw the line, and this is your final P dash Q dash. So that is nothing but your elevation, and this is the plan, or top view, or this will be your front view. So this is your this answer, and you can cross check this answer by drawing a line here. So that is nothing but connect Q dash and Q with a thin line, right? So that will be your cross check. You can cross check, and this is theta. We need to find the inclinations, and this is pi, and pi and theta I am getting 34 degree and 25 degree. Now you please cross check this, and if you are getting this, the answer is 100% correct. So this is the seventh problem, and if you want to conclude, right, you should write at the end, right, all dimensions are in mm. So now it is the complete solution. Don't miss to show the direction of rotation, and you should not miss to write all dimensions are in mm in one side of the sheet, right? So this is the answer. We will see the next problem. Eighth one, a line AB of 75 long, true length is given as one of its ends 60 in front of VP and 20 above HP. The other end is 20 in front of VP and is above HP, and how much it is above HP is not given, and the top view of the line is 55 long. So draw its front view. So this is the top view length is given, and the true length is known, and the as its one end, right, is 60 in front of VP and 20 above HP. So other end distance in front of VP is given, above HP is unknown, so that should be find out. Instead it is given top view length. The top view length is given directly. It means that AB, right, it is smaller case letters. AB length is 55 so it is also a similar kind of problem earlier we have seen, and here in same steps we can solve this. So one end is 20 above HP, so this is 20 above HP and 60 in front of VP. So this is our A dash and A, and now top view is known, that is 55 so 55 at 55 you can draw a projector. So this is A and this is your B1 dash, so sorry, B1, it should be B1. So this is A B1, and we don't know the locus of B, right, we don't know the locus of B here. So now we know the true length, it is 75 it is 75 on this line. If you cut 75 on this line, we get its true length line. So this is the true length line, 75 and this is our corresponding locus of B dash. So this will be our locus of B dash, and this is our projector. So now this is first step is finished, right, first step is finished, and in front of VP distance is given. The other end is 20 in front of VP, so this is 20 and this becomes our locus of B. Now we can rotate this up to here, right? So this will be our final top view. This is our final top view, and now we know the true length. We can cut the arc 75 from A as center, and we can cut the arc on locus of B. So this becomes our B2. So from here you project up to here, up to locus of A, and this is our A B2, and locus of A, this is our B2 dash. Now you rotate it in our usual procedure. Now take A dash as center, A dash B2 dash as radius, rotate till it meets B dash line, locus of B dash line. So now this is our final front view, so that becomes final front view. So you can cross check this answer, and this is our it is exactly lying on this projector. It is perfectly correct. So draw all dimensions are in So this is again a simple problem to solve, and the unknown distance is only locus of B. So point B is not known, but from top view we can easily find it. So that is only the trick in this problem. And next is ninth problem. The end P of a line PQ 70 is 70 long is 15 above HP and 20 in front of the VP. The end Q is 40 above HP, and the top view of the line is inclined at 45 degrees to the VP. Draw the projections of the line and find its true inclinations with VP and HP. So we need to find theta and phi. theta and phi. So it is also again a simple problem. Draw XY reference line 15 mm above HP. We have end P, and this is 20 mm in front of VP. We have end P, and P dash and P is on the same projector. So this is P, and this is our one projector. So this is our fixed end, and at 40 mm above HP we have the end Q, right? So this is locus of Q, and the true length is given, it is 70 mm. So we can cut an arc on this and we get the Q1 dash. So this is our Q1 dash. Now if we get to Q1 dash, you will get the Q1 on locus of P line, right? So this is 45 degrees. The top view of the line is inclined at 45 degrees, so that is nothing but beta angle is given. And now if we project here, right, so now we have to rotate till this line to get our final top view. So this is our Q1. So PQ1 should be rotated onto this line, 45 degrees line. So if we rotate this, we get the final top view. So here this is P point, and this is 45 degree line, and PQ1 as radius, P as center, right? Rotate this till it meets this thin line. Now you can mark a point that is nothing but Q, the final Q, and this is your top view. This is the top view, and draw the locus line, and that becomes locus of Q. So this is a locus of Q dash and a locus of Q, and once you get this Q, it is easy to get the another projection. So now we know the true length. From P you can cut an arc 70 mm. So from here you project up to locus of P dash, and this is our Q2. So this Q2 dash you will obtain here. So this is Q2 dash, and now as usual we should rotate P dash as center and P dash Q2 dash as radius. Rotate this and you will get the final front view. Now you can cross check your answer by drawing a projector, and it is lying on the same projector. Now we need to find its true inclinations. I am getting this much. So theta equal to 20 degree, phi equal to 40 degree, and please cross check your answer, and if you are getting the same answer, well and good, and that is ninth one. And we move to 10th problem. End A of the line AB of 75 mm long is 50 mm in front of VP. So true length is given, and A distance is given from in front of VP and 15 mm above HP. So end B is 15 mm in front of VP and above HP. So end B above HP distance is unknown, and the top view of the line is measured to be 50 mm. Determine the length of its elevation and true inclination of the line. So we need to get theta phi and the length of its elevation, that is the front view distance, that is nothing but A dash B dash distance. So these three we need to find here. It is also very similar problem to earlier problem. Draw XY reference line at 15 mm. Draw the one end. So it is the locus of A at 50 mm in front of VP, and now you can mark A dash and A on the same projector, and this is the another end. So we know in front of distance above HP it is not given, and this will become our locus of B, and we know the true length. So from A we can cut the arc. It is 75 mm. Sorry, it is 50 mm long, right? It is 50 mm top view. So either you can mark here and you can rotate it, otherwise you can directly draw here, right? You can cut the arc. So this is the final top view. So this is the final top view. It is nothing but 50 mm. It is 50 mm given in the problem. AB you have obtained. Now from here you can rotate it. You can rotate up to locus of A line, and you can project it up to A dash locus line, right? A dash line. So you can draw the line, because you know the 75 mm true length, right? From a dash you can cut the arc. We did in the earlier problem also, same procedure. You can follow the same procedure, and this is the 75 mm long. Now you are getting a dash and b1 dash. So this is a dash b1 dash. Immediately you can mark the locus of b dash, locus of b dash. Now you have obtained the top view, and from top view, right, you have obtained the locus of b, because the above hp distance is not given. In front of vp it is 15 mm clearly given in the problem. So now you know the true length, it is 75 mm long. From a as center, 75 mm as radius, cut the arc on the locus of b, locus of b. So even in this problem you can start in this way also. From a b2 dash you can obtain, right? So from b2 dash you can draw this, and you can go in that step also. So this problem can be solved in different ways, right? So whatever way you feel comfortable, you can solve this problem. And as I said, right, all steps are involved within those 5 steps. So this is b2, and this is our b2 dash, this is b2 dash. And now as usual, a dash b2 dash you should rotate, right? And you will get the b dash. So to rotate this, a dash and b2 dash has radius, a dash has center, you rotate up to locus of b dash, you obtain b dash. So this is your final projector. Draw the thin line, and you can cross check this, and find out, measure all the angles. So theta and phi, right? I am getting theta equal to 48 degree, phi equal to 28 degree. That is, the elevation length is 66 mm. Elevation length is 66 mm. That is nothing but front view. So this is the 10th problem. The similar kind of problem we will see one more problem. So this is 11th. The top view of the line PQ makes an angle 30 degrees. So top view angle, so this is nothing but beta. The beta angle is 30 degree with the horizontal, and also has a length of 100 mm, right? So the top view is 100 mm. The NQ is in the HP, and P is in the VP, and 65 mm above HP. So the one end is in HP, that is, the second end is on HP, first end is on VP. So that is the speciality of this problem, right? So we have solved this kind of problem in the class with 3 different steps. Now I will show you in rotating line method. So this method you can use very effectively. You can do when you have drafter. Without drafter, don't try this method. And draw the projections of the line, and find its true length and true inclinations with the reference planes. Also traces are not required. So draw xy reference line at 65 mm. Draw the locus line. So this is your first point, p dash, and p is on VP, right? So p is on VP. So this is our P. P is on VP. So P is on VP. In front view, it is above HP. So in top view it is on XY reference line itself, since it is on VP. So the 30 degree is given, right? The angle is 30 degree. So this is the final top view. So this top view is obtained by rotating the line, right? By rotating this. So this is the 100 mm. So here this is the locus of Q, and you can rotate this and mark this point as Q1, right? So since the Q is on HP, right, Q is on HP, right? So this will become your Q dash. So locus of Q dash. And from here, right, you draw a thin line to join Q, that is P dash, and this will become your Q1. So this will become your Q1. So this is your true length. Now in this step itself you can find the true length. Now you, after finding this true length, from P you cut the arc, you get the q2, right? q2, and you project up to p dash, so up to p dash line, up to p dash line. So this is the very simple method if you have drafter. Otherwise you can do in three separate steps as I demonstrated in the regular classroom. So that way also you can do, but if you have drafter, it is very simple to solve in this method also. So this is your q2 dash, this is your q2 dash. Now p dash and q2 dash as radius, rotate up to this locus of q dash line. It is obviously your xy reference line, and now this is your q dash. So this is your q dash, and join this line with thick line. Now you see P, right? P, top view of P is on XY reference line, and the front view of Q is on XY reference line. It means that Q is on HP, P is on VP. So that is the significance of this problem. So now you can join this using a thin line, and this is your theta, and this is your phi. So theta and phi both you can find. So theta I am getting 33 degree, phi I am getting 25 degree, true length is 120 mm. So this is the problem, and one end is in on HP and another end is on VP. So that kind of problem this is, and very easy to solve using this method, or you can also solve using those three steps. So I have done in three different steps in the class. So that way also you can solve this problem. Both way you can do, but whatever may be the method, you will get full marks if you are getting these values again. So please cross check this answer, right? All dimensions are in mm, and these are the kind of problems, right, where true length or some angles are unknown, right? So it is easy to solve these kind of problems. We will see more number of problems again.